Now that we've created our static types for the physics.js library in the last video, we're now ready to add some physics to our game. In this video, we're going to be adding physics to a circle and simulating gravity to see the ball drop. Let's get started. The first thing we need to do is add the dependency on the physics.js library. In the last video, when we created our static types, all we did was create types for physics.js, but we never added the original library itself. So to do that, I'm going to use WebJars. So I can go to webjars.org. WebJars is really awesome. They have a bunch of Node and Bower libraries, and they make these libraries available as jars that contain the resources from those libraries. And one really cool thing you can do is you can either manually create a WebJar, and they have documentation on how to do that, but a recently added feature is that you can generate WebJars from a Bower or NPM package. So that's actually something I did for physics.js because there wasn't a physics.js package in WebJars before, but I just typed in the name of the Bower dependency, physics.js, selected a version, and then within a few minutes I had physics.js. And all you have to do to add a dependency on a WebJar in scala.js is go to your build.spt and do JS dependencies plus equal to, you paste in that WebJar code, and this puts a dependency on that WebJar, and to specify which file you want to include as a JavaScript dependency, you do slash and you give a path to that. And to look at all the paths of all the files, you can click View Files, and then you can see all of the files that are here. So we want dist slash physics.js dist slash physics.js dash full.js. I don't know what is wrong with my voice right there. So I'm going to paste that here. So we have dist slash physics.js dash full.js. And now we can actually see IntelliJ already went ahead and reloaded the SBT project, and we should do the same here. So I'm going to reboot my SBT here. So now it's going to refast optimize, and we can actually see in our target we now have a hello Collidium dash jsdeps.js, which contains physics.js. Now if you want to load up physics.js, or we need to add it in our index files, so here I'm going to do dash jsdeps, and I can paste this into the full opt as well. And now if we reload our Hello Collidium page and inspect element, if we go to our console, we can type in physics, and we can see that we have the physics.js library loaded up here. Now we can go ahead and start integrating it into our main code. So I'm going to go to Sprite. So we have this existing class circle. Now what if we want to create a subtype of class that instead of having a set location, it gets its location from physics.js. So what I'm going to do is I'm going to create a trait physics, and the physics trait is going to be a mix-in for sprites that allows the sprite to get its location based on the physics engine. So to specify that it's a mixin for sprites, we can do this colon sprite. So now we're saying that the type that this is being mixed into must be a sprite. Now that we have this, we can start and override location. But before we do that, we need to have implementable values that specify what type of body we're working with. So I'm going to create, first we need to know which world we're adding it in. So we're going to have val world of type world. And we already have our physics.js facade here, so we can actually code complete this. We need our shape type, which is a string, as well as a shape setup of type shape setup, and code complete again. So that's a nice thing with having your facade. Now I'm going to create a lazy val body. What I'm doing here is I want to create the body for my for this physics engine. But one tricky thing is that the constructor for this trait may be called before all of these are initialized. For example, when we implement the physical version of a circle, world is going to be taken as a constructor parameter. So if we try to access it in the traits constructor, we won't be able to access it. So for that reason, we're going to create a lazy val body, which will only be evaluated when it's needed. Now, what we need to return is physics.body, and body takes a shape type as well as a shape setup. We want to add this to our world, and we're going to return that body. And now when we override our location method, all we're going to do is return a point. We're going to do body.state.position.get0. This gives us our x, and we need to convert this to an int because we want an int, but physics.js gives us a double. And we're going to get our y coordinate. And that's all we need to implement a physics mixin. Now to actually use that with the circle, we can do a class physics circle. We can copy all of these parameters, but I'm going to rename underscore location to initial location. This is going to extend a circle, and I'm going to actually put this on the next line. And we copy these, but we need a physics with physics. And this actually kind of flows nicely like English. It's a circle with physics. Now we're getting a compile error. It's saying that there are unimplemented members. So first let's start with world. We're going to just take world as val world type world. So a constructor parameter for physics. So now we have that implemented. Now we need to implement shape type and shape setup. So this is going to define that this is a circle and how it should act. So we're going to create val circle means shapes type circle, and we need a shape setup, and this is going to be circle. Let's go to our physics thing and see what's the name. Circle setup. Yep. Circle setup. We're gonna create a new one, and our x is initial location.x. Our y is initial location.y. Our velocity x is 0. Velocity y is 0. Our treatment is it's going to be a dynamic for now, and our radius is going to be our radius. And that's all we need to implement a physical circle. Now we need to integrate using this engine into our main so that we can see this working. First thing I'm going to do is create a world. Val world is equal to physics, and we're just going to do that apply that we created here to create a new physics. Then I'm going to actually take this sprites and move it out, because we're not going to move around our circle based on the iteration anymore. We're going to use physics. So our x is going to be 250, our y is going to be 50. So we start this out in center at the top. And what I'm going to do is I'm going to change circle to physics circle. And we're going to pass our world here. Now we can get rid of cur x, cur y. What we want to do is we're going to get rid of dom.setInterval because we're going to use the physics.js ticker type instead. So let me load up physics.js. Here we go. I'm going to go to the API reference and we're going to use ticker. So ticker lets us have a periodic function that will be called by physics.js. So I'm going to go to physics. I'm going to create, and this is the object ticker extends js.object, and ticker is located under physics.util.ticker. So we can put an @js name, and you can see here how the @js name is useful because now we can have a clean name in our Scala code, ticker, but it still references this long physics.util.ticker. Now on ticker we have a method on, which sets a listener, so def on, which takes a function, and this is going to be from the current time to unit. So this is going to be double to unit. This is going to return unit of type js.native. And we have another method, start, here, which takes nothing and returns unit and js.native. Now we can use this. So instead of doing dom.setInterval, I'm going to do ticker.on. And we're going to take time of type double. So these two lines we're going to keep because that's our rendering. But before we render, we want to update our physics world. So we're going to do world dot, and we have to go to the world type and step. So world has a method step which takes a timestamp to move to, and we're actually going to directly pass time to it, but we need to actually add this to world first. So we're going to have def step, which takes time of type double, returns unit, and is implemented by js.native. Now here I'm just going to do world.step to time, and we don't need to provide this. And the last thing we need to do is start our ticker. So we're going to do ticker.start. Now we can go ahead and reload this here. I'm going to open up inspect element just in case we get any errors. So we have an issue. Handler is not a function. Let's take a look at what happened here. So we have time of type double to, let's take a look at this source, 2908. So let's go to target scala JS steps, and you want to go to line 2908. Scroll a little bit. 2953 2908. So they're trying to use our handler in our physics engine for ticker. So let's take a look at what happened here. So let's go to physics So we have ticker on, which takes a function of type double T unit. Let's make sure that that matches up with what they expect. So we have a ticker on a function which takes time, which is a number. Aha! I figured out what went wrong here. What we're doing is we're using a Scala function. What we need to do instead is use a js.function1, which takes double and unit. So this is saying that it's a JavaScript function. Now we can go ahead and switch over to Chrome, reload this, and now we see our circle here. But it's not moving because we don't have any forces acting upon it. So we need to add gravity. Now the way we're going to do that is physics has a method behavior. So where's behavior? Here. And behavior takes a name, and one of the behaviors is constant acceleration, which is another word for gravity. So we're going to add the method def behavior name of type string. This is going to give us a behavior js.native. And we actually aren't going to be calling any methods on behavior, so we can just create a trait behavior. And this is going to extend js.object. But we don't need to implement any of the methods because we don't care about calling anything on a behavior. We're just going to be passing it off to our world. Speaking of passing it off, we need to add an alternative add method, which instead of taking a body, takes a behavior of type behavior. Now, to make things fall, I'm going to do world.add physics.behavior constant acceleration. And we now have a falling ball. And we can see this constant acceleration because it's speeding up as it falls. So now we have a physics engine working, and we're even rendering different things based on how things are moving within our engine. In the next video, we're going to be working on adding a few more objects that we're rendering to our physics engine so we get a bouncing ball. I'll see you then.